Today is September 18th. So if you take out your notes to the section that you were at, you can add the date. Hopefully you've been doing a good job of keeping things organized. And today we work more with fractions. I do have a pencil you can borrow. Do you need loose leaf as well? Okay. So again, you've probably learned the rules for fractions before. That's great. If you remember them, awesome. If you can do this question already, perfect. But one of the things that we're going to try to do is really try to understand what's happening here. Rawson, you ready for this? Oh, here we go. And Rawson, do you have some paper that you could take out so that you could write this down? You know what? I can lend you a piece of paper then. So even if we know the rules, one of the things we're going to do is we're going to try to understand what's happening. Okay? So you can write this down to begin with, but right now, this next little part, you can just watch. Okay, I'm going to pull out my chocolate bar color. We're going to say that that's one whole, that's one chocolate bar. So if we had 1/2, would you agree that that piece represents 1/2? Okay? And if we split this chocolate bar into thirds, that piece there would represent 1/3. And so the question is, and this is why it really is a hard question, if we had 1/2 a chocolate bar plus 1/3 of a chocolate bar, how much of a chocolate bar do we have? So here's our 1/2 of our chocolate bar, and here's our 1/3 of our chocolate bar. Can you see that you don't quite have a whole chocolate bar yet? If I put those right underneath the chocolate bar, it doesn't quite add up. How much of that chocolate bar you have is a very difficult question if you were just dealing with these quantities. So what we do with fractions, and if you want to start writing out the rules, one of the rules you're probably told is, first of all, you need to find a lowest common denominator. Or a common denominator, often when you're talking about the rule, someone will just say, you need to find a common denominator. So we've got an important word here. The word denominator, those are those numbers on the bottom. And when you're finding the lowest common denominator between 2 and 3, what you're trying to find is, if you went through your times table with 2, 2, 4, 6, 8, and you went through your times table with 3, 3, 6, 8, 12, 3, 6, 9, 12. If you went through those, do they have a number in common? And that number is 6. So we have a common denominator of 6. Now, the reason we would want to separate this into sixths, okay, I'm going to move my 1/2 piece up here, and I'm going to draw a blue line where 1/2 that chocolate bar was. I'm going to move my 1/3 of a piece in here. I'm going to draw a green line where the first 1/3 is. I'm going to move this piece over. I'm going to draw a green line where the second 1/3 is. And again, your focus at this point has to be really, really good, because there's a lot of explanation here, and at the end of the day, you have to try to understand this in order to be able to do this mathematics. And if you see what's happening, if it makes sense to you, then the rules are going to make sense. So we've got the blue line, everybody okay with that, representing a half of the chocolate bar. And the green lines, each representing 1/3. Now, if you took each of your thirds and cut them in half, if you took each of those thirds and cut them in half, can you see that you would get 6 pieces? Okay? And so one of the things that we're going to write in this is we're going to say that 1/2 is the same as 3/6. And 1/3, that's up to that green line. Does that make sense that that's the same as 2/6? In other words, once I cut everything into 6 pieces, the 1/3 is 2 of those 6 pieces. That 1/2 up to the blue line is 1, 2, 3 of those pieces. And so if 1/2 is 3/6 and 1/3 is 2/6, then we can say that 1/2 plus 1/3 is the same as 3/6 plus 2/6. So if we want to write our second step, what we've just done is we have just written each fraction with the same lowest common denominator. And the number in the bottom of a fraction is telling you how big it is, what size it is. So we started off with a half. And that means we have one piece that's half the chocolate bar. Then we changed that to 3/6, saying now we've taken that chocolate bar, split it up into 6 pieces, and we have 3 of them. And when you're adding fractions, if you have a common denominator, you have 3 pieces plus 2 more pieces that are the same size, you're going to end up with 5 pieces of that size. So when I write this as a final answer, I can now add 3 plus 2. It should make sense because I have 3 pieces of that size. In fact, I could take this half and draw those 3 pieces in there, and take this third and draw it into 2 pieces. And then I ask myself, well, how many pieces do you have? You have 5. How many pieces of that size do you need to make the whole thing? You need 6. So our final answer becomes 5/6, because we have 5/6 of the whole thing. If I move these chocolate bar pieces back in, not those red dots out of the way, this one comes up to half. This one matches up to there. We have 5 out of the 6. We're just missing that little bit that's left. Now that's trying to understand what's happening, right? What did we do after we had them each as a common denominator? We added or subtracted. In this case, we added. We added the numerators or the tops. You don't add the bottom because the bottom is telling you the size of the pieces that you have. It's almost like a descriptor. When you have 2/6 plus 3/6, you end up with 5/6. The 6 is just a describer. It's like if I said you have 2 oranges plus 3 oranges. Nobody would say, oh, I have 5 apples. No, you have 5 oranges. That number on the bottom describes the size of it. Now, sometimes with your answer, you might have to write it in lowest terms. That's a terminology that you've probably heard before. What that means is if you had an answer that ended up being 3/6, since both the top and bottom number can be divided by 3, we would write it as 1/2. 1/2 would be in lowest terms. Okay. Here's our next example. 3/5 plus 2/3. How do you guys want to proceed? Do you want to just see the math first and see if you are able to do it with just the math first, and then have the explanation with understanding it using chocolate bars or whatever item we want? Or do you want the understanding first and then the math after? So understanding first. I'm going to represent the 3/5 on the first chocolate bar, the 2/3 on the second chocolate bar. So the 3/5 would mean that, and you have to use your imagination a little bit because my drawing's not perfect. Your imagination has to be that all of those blue pieces are perfectly the same size. With the second one, the 2/3, I'm going to represent that one in green. That means this chocolate bar is split into 3 pieces, and we have 2 of them. So to visualize what we have 3 of these pieces. And we have 2 of these pieces. And we have to try to imagine if we put those all together back into this chocolate bar, 3 of this piece and 2 of this piece. Looks like we have more than a full chocolate bar. But what that number is exactly, so I'm going to say, I think I have 1 chocolate bar and a bit more. How much is that bit more? How much would it be exactly? Okay? So what we need to do, step 1 was find that lowest common denominator. How could we cut this chocolate bar into different pieces so that in the end everything is the same? Oh, can I have a good idea. I'll do it for the next one. Okay? For this one, I'll stick with what we did the first time. Oh, I really like my idea though. But we'll look at it in the next one. So in this one, the question is there a number? These are our denominators, the 5 and the 3. If we're looking at the multiples of 5 and the multiples of 3, again, we really need to know our times table. What number do 5 and 3 have in common? 15. Right? Count by 5s, 5, 10, 15. Count by 3s, 3, 6, 9, 12, 15. That's the first one that they have in common. So then our job is to rewrite both of these as something over 15. Now 3/5, if we want to write it over 15, we go, oh, I would have to multiply 5 by 3 to get it to equal 15. So that means I also need to multiply 3 by 3 to get it to be 9 over 15. In other words, in order to get 15 pieces in this first chocolate bar, I would need, I'll take out my red pen, to split each piece into 3. Oh my goodness, maybe I'll start drawing solid lines. Can you see that if you split each blue piece into 3, Again, imagination just a little bit that those pieces are all the same size. I'll draw these with solid lines. Can you see that we have 15 pieces? If I took 5 pieces and each piece I cut into 3 pieces, I'd have 15 pieces. And in my thirds, what would I have to split each of those green pieces into in order to get 15 in total? I'd have to break each of these into 1, 2, 3, 4, 5 pieces. If I broke each of those 3 pieces into 5 pieces, does it make sense that I would get 15 in total? So now I've got all of those cut up. And if I had 2 of those, and this one had 5 pieces, and this one had 5 pieces, my 2/3 is going to equal my 2/3. How many pieces do I have in total? I have 10. Mathematically, what have we done? Well, each of the 3 pieces was split into 5, making 15 pieces in total. But if I only had 2 of those pieces, with 5 pieces each, I would have 10 15ths. So 10 15ths is equal to 2/3. So step 1 in doing our math is we find out what that common denominator is. In this case, it's 15. We imagine our chocolate bar being split up into 15 pieces. Okay, definitely starting to look like a really, really long Kit Kat bar because all the pieces are long and narrow. And now if I have these ones are split into 3s, 1, 2, 3, 1, 2, 3, 1, 2, 3, making 9 pieces. And these ones are split into 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 pieces. I have 9 pieces here, 10 pieces there. How many pieces do I have in total? I have 19 pieces in total. What size are those pieces? They're 15ths. So again, step 3 that we wrote down before is once you have that common denominator, you add the numerators. Why do you add the numerators? Because that's how many pieces you have. Why does the denominator stay the same? The denominator stays the same because the pieces, if I have 9 pieces that are this big plus 10 pieces that are this big, the size of the piece stayed the same. It's still a 15th of a chocolate bar. So when we add them now, we have 19 over 15. Can you see that the 19 is bigger than 15? I mean, as soon as you take out 15 of those pieces, you get 1 full chocolate bar. How many pieces are left after that? 4 pieces are left. So we can say as a mixed fraction, our final answer is 1 4/15. We have a whole chocolate bar plus 4 extra pieces that are all the 15ths. I want you to try this one, but what I'm going to get you to do, I'm going to just change this to 1 over 4. No. Here's my new chocolate bar. You like that? Is it not the right color? Perfect. There's our brown chocolate bar. We have two of these chocolate bars. One of them is split into quarters, so that means it's split into 4 equal pieces. The other one is split into 6 pieces. Between 4 and 6, what's a common denominator? 12. So then, we have 12s there. Why is it 12? Well, you got 4, 8, 12. And you also have 6, 12. Those are multiples. So if I wanted to go to my chocolate bars that's in 4s, what would I need to split each of those pieces into to get 12? I'd have to split them each into 3. Does that make sense? If I split the first piece into 3, the second piece into 3, the third piece into 3, and the fourth piece into 3, then I get 12 pieces. Mathematically, right, you're not always going to be drawing out chocolate bars. They're there to help you visualize, and at the beginning, as you're trying to understand it, you might do that. But mathematically, what we're going to do is we're going to say, if I have 1/4 and I want to make it something over 12, I have to split each piece into 3. And so I'm going to multiply this by 3, and sure enough, 4 times 3 is 12. But then 1 times 3 on the top is 3, because if I only have one piece and it's split into 3, that means I'm going to have 3 pieces. So here's what we have so far. Here's our blue piece. It's here. And that blue piece we split into 3. And now our 6ths. Okay? What would I have to split each of my pieces that are 6? What would I have to split one of those pieces in so I get 12 pieces in total? 2. So if I cut each of them in half, cut this one 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 in half, this one in half, this one in half, I'm going to get 12 pieces in total. And so we would say 1 over 6 is equal to something over 12. Well, we split each piece in half. 6 times 2 makes the 12. And if we look at just one of those pieces right there, one of those pieces is 2 12ths. And if we add that onto here with 2 12ths, this is how much we have in the end. We have 3 12ths plus 2 12ths. If we add those up, how many pieces do we have in total? We have 5 pieces out of the 12. Now I want to show you a technique that works, but it doesn't always use the lowest common denominator. And this is a great example to use it for. Okay? So has everybody copied everything they want to right now for this one? And I really like this technique because I think, there's my 2 chocolate bars. Okay. Again, I'm going to take my 1/4, but instead of doing 1/4 the way that I did last time, I'm going to draw the 4 pieces this way. Does that still make 1/4? Each of those pieces still 1/4, even though I cut it a different way? Yes, because now they're longer, but they're still all the same size. Again, use your imagination a little bit. They're all the same size, it's still 1/4. And I'm still going to do my 1/6 this way. If I put those together on this chocolate bar with those lines, I'm going to draw my 1/6 this way. Oh, this is cool. And I'm going to draw my 1/4 this way. This is really starting to look like a chocolate bar. Because usually, like, chocolate bars have those little square pieces. They don't have, like, super long, skinny ones, unless it's a Kit Kat. But this is more typical. Now, if the blue lines and the green lines were put together, how many pieces would you have on that chocolate bar? 24. Okay? So instead of doing 12ths this time, I'm going to do 24ths. If you had one blue piece, which is a whole top, how many pieces would you have? 6. If you did one green piece, which is like this, how many pieces would you have? We're ignoring the blue. Oops, sorry. Throw that away. Throw that away. If we're just doing one row this way, if you took it with the whole thing, you would have 4 pieces. So if you took one row this way, which is 6 pieces, and one row this way, which is 4 pieces, how many pieces would you have in total if you added them up? 10 pieces. Visually, I think someone can see this way better than the 12 that we did before, cutting them all into little pieces. It's really easy to take ones that are horizontal and ones that are vertical and put them together and get 24 pieces. 24 isn't the lowest common denominator, but it's still a common denominator. When I get my final answer, 10 out of 24, that answer is correct, but it's not in lowest terms. In lowest terms, you have to check if the number in the numerator and the number in the denominator, if they both can be divided by the same thing nicely, then you can reduce it. Is there a number that divides 10 and divides 24? 2. If I divide 10 by 2, I get 5. If I divide 24 by 2, I get 12. That's the same answer that we got before. But the drawing and everything else made it a little bit easier. Especially for this one. Chocolate bar number 1, chocolate bar number 2, chocolate bar together. In one chocolate bar, we're going to break it into 7ths. So we do our best of our ability to make 7 equal pieces. I can take those blue pieces and click them onto there as well. Then we're going to take our second chocolate bar, which is in 5ths, and we're going to split it into 5 equal pieces this way. putting those together, your chocolate bar has how many pieces? If I cut it into 7 this way in the blue, 5 that way with the green, put it together, how many pieces do I have in total with the green and the blue together, those little squares? 35. And again, our times table comes in, right? Because 5 this way, 7 this way, that's going to be 7 times 5. You can always find a common denominator by multiplying the bottom two numbers. It's not always the lowest common denominator, but it will work. So now, 3/7 is going to be something over 35 plus something over 35. How much is 3/7? It's 1, 2, 3 blue pieces. If I took 3 blue pieces here, if I took 3 blue pieces there, how many pieces do I have in total? 15. Okay? Really easy to see that. 15. Again, off to the side, what have we done mathematically? To get that common denominator of 35, we multiplied the bottom by 5. And when you have 3 of those pieces, we multiply that by 5. That gets you the 15. But again, you can really see it easily from the picture. Next, we look at having 2/5. That's 2 of those long green pieces. How many would that be out of 35 in total? How many pieces do we have if we take 2 bars that way? Pieces. And so we can say off to the bottom here, I know that 2/5 out of the 35, well, I had to multiply this by 7. I made a mistake. I counted wrong. Nobody caught that? Nobody said anything? Is that 10 pieces across the top? How many is it? 7 this way, another 7 that way. It'll be 14. Thank you. 14 pieces. And sometimes, this is a good example, sometimes what's going to happen when you're doing your math is you're going to write down the answer, but if you check it somewhere else, it might show up to be different. So then you might have to think about a little bit more what happened with that number. Now, if I have 15 pieces plus 14 pieces, I'm going to end off with 29 pieces out of 35. You have to know your times table and say, what are numbers that can divide 35? 5 and 7. Can you divide 29 by 5? No. Can you divide 29 by 7? No. So this is in lowest terms. But again, knowing your times table becomes very important for that. So one thing you should be trying to do as much as you can, whenever you can, is practicing your times table all the way through. So here's one for you to try.